Hello everyone, I'm Isaac. I want to demonstrate how we carry out analysis of variance using R. One-way analysis of variance using R. And I want to make use of an example displayed on the screen. It's on user satisfaction across different website design. We have different website design. There are three. I have design A, design B, design C. So I want to make use of one-way ANOVA to analyze differences in satisfaction level. These are satisfaction level. These are the scores out of 10. People are interviewed and they are scored. Design A, design B, design C. So these are the results. You want to see whether there's difference in the means, in the three means of design A, design B, design C. If there are two, you just use t-test. But since the levels are we have more than two groups. That's why we are using analysis of variance. What makes it one way is because it's only one factor determining this. If you have another factor now, maybe location, it will become two-way. So I'm going to use RStudio. So you can export this to RStudio or you type the data out. So this is it. And these are the libraries, satisfaction data. I call it satisfaction. You can call it any name. So this is data frame. You run it. When you run it, already you have the results. Let me delete these results. I run it and run. So you see, then you run this now. When you run this, so once R is not giving you any error message, it means it's correct. How do we see this data now? You can quickly run this data here. See this data. You can see design. You can see the score just as we have it here. The only thing is that I did not add design, but design is at the top. If you want to add design, you can see design A, design B like that. So this can be seen in the table. When you look at this table, this is the satisfaction table. Then the first thing to do when you look at the question says determine whether there is difference across the three different web design in terms of user satisfaction score. Well, you need to describe it because under description you're going to see the mean, the median, standard deviation, and all the rest. So this is pipe. You can use this. You can get this function from the library dplyr, or you install tdvars. So that's why you get this. So then this is summary data. What I'm trying to do here is I want to group. You see, this has three groups. Design A has three values, score 1, 2, 3. B has 3, 1, 2, 3. C has 3. So this group by, we break this. I want you to break it by design. So if you are using SPSS, we have it will ask you, you are going to define the group by what? What are you using to define your group? You have to let it be listed. So we use this group by, and you are using design. If it's gender that is here, most time the factor we normally use to group is not numeric. They are categorical. So you are using score to group. Then that's why you have design here. Then you now use pipe. We use pipe to continue with our code. Instead of putting comma or you go down another line, no, everything can be brought together here. So if I give you this now, you give me, to do the summary. To do the summary, the mean of score by group. What's the mean of score by group using the first? For example now, 8.2 plus 7.8 plus 8.0. add divide by 3 give you the mean of A. 7.5 plus 7.6 plus 7.7 you give divide by 3 give you, and so on for this, give you the mean for these three. This is what it's doing. Same thing for standard deviation. So if you want to do for variance, put it there also. So let me run. So this print summary will give it to us. So you can see. So for design A is 8, for B 7.6, for C, and so on for the median and standard deviation. So if you want to revise, just do it manually, you get it. Then one-way ANOVA now. Of course, from this place you can easily know that is there any difference between these three. The difference is not significant to the way I'm looking at it, but because this is 8, this is 7.6, 8.4. The three of them are almost the same category. And even if there are variations, 0 points, even their median, they are almost the same thing. So let me run. Let me see. It may be significant. In fact, I'm wrong. It's significant because okay, summary ANOVA, this is 0.00137. It is significant. That's why it's not good to stop at descriptive statistics. You don't just stop at mean. Yeah, the mean are close. Though they are close, but they are not equal. The variation is still there. So you can see that because the result we have here shows that there is significant difference in the mean of the design, the score of the design. So we have this significant. Then let's visualize it. The significance will be shown visually. So you can see the box plot. Box plot is very good when it comes to showing variation. And the main plots with error bars will also show it. So the box plot, the alpha. So what does this one is ggplot. Ggplot will give it to you, and you can see the labels, the website design, and the main plot with error bars. Then we give it to us. Then the mean and the mean satisfaction scores. So let me run this. You are free to change the color. Now I want to explain this. This is what we call box plots. See design A, the color is A, this is design B, this is C. Now these three design, you can see that the one with the highest mean is this, and that is C, almost 8.4, followed by design A, the last one that has the lowest score is a website design B. So then we can at the same time check for that main plots. Then in terms of variation, so we have some dots outside here. The one that are more compacted together, the variation is not too high from one another. In terms of data point, is this this B. See the point. The points are not too far away. This one far, and we can check that. I quickly check that even in the data. See B 8 point, no, B has 7.5, 7.6, 7.7. You can see the variation, the standard deviation here will be very low. B. So that's how to interpret box plots. You can see B 0.1, lower than this. Then next one is the next visualization is main plots. Main plot, you can see main plots. So main plot is here. So it's just showing that these are error bars. People in biosciences love this. If you show the error bars, you can see mean distribution plus or minus standard deviation. So it's still showing to us that one has the lowest error. You can see the tail. This one is the longest. So showing that the one with minimum variation are this. This one has higher variation. So with this, we have done it. But to cap it all, you can conclude by saying that there is significant difference in the mean score or the website design across the group. Thank you.